Go.
We are going to do problem number 43 and 6.5, and we are asked to solve this problem. Since we have 4 terms, this polynomial, we are going to factor by grouping. So now the first thing in factoring by grouping is we're going to break this into 2 parts, a first part and a second part. And we're going to put a plus sign in the middle, so that way this sign in front of the 2R stays with it. This will help you differentiate where each sign goes. Now we're going to look at each of these 2 separately to decide what we can pull out. This is like your greatest common factoring. So the first thing we're going to do, in this, we can see that we don't have any coefficients we can pull out, but we can pull out an r squared in both. And that leaves a 2r in the first one and a 5 in the second one. Now on this second term, you can see that we don't actually have an r we can pull out, nor do we have a coefficient. But we have this negative in front of both of it, so we're going to pull out a negative 1. Leaving a 2r plus 5. Now you can see now we have the same term in each. This means we have achieved what we wanted with grouping, and we can pull that term forward, 2r plus 5, and we are left with the remnants, the r squared and the negative 1. Now, are we done factoring? You always want to ask yourself at this stage, have I done all I can? In this case, the answer is no. You can still factor this r squared minus 1. This we're going to use our special factoring rules. And this says that if we have a perfect square, in this case 1 is a perfect square, we have 1 of each of the roots. So we have plus 1 and minus 1. Now we look again. We have all single r's, so we're done. We're done with factoring, but now to solve this equals 0, we use our 0 factor rule, which says that each of these can be set separately to 0 and solved. So 2r plus 5 equals 0, and r minus 1 equals 0. Now we can solve each of these separately. So in this case, this is 2r equals negative 5, r equals negative 5 halves. This one, r equals negative 1, and r equals 1. So we have 3 answers to this problem. We have negative 5 halves, negative 1, and positive 1. Now if you want to check this, remember you can take each of these, plug them back in for r, and solve. I'm going to do one example for you. You can do the others by yourself. So let's do one. You can see it easily, quickly. This is 2, 5, 1 squared, minus 2 times 1, minus 5. So we have 2 plus 5 minus 2 minus 5 equals 0. So we have 7 minus 7 equals 0, and that checks.